Hello everyone, this is Mohammad Jahangir Hussain from MDH Math Assist. Today we are going to solve a paper from October number 23, S1, paper 5, version variant 52. Okay, without any further ado, let's get into the question. Okay, this is the question we are going to solve today. You see, from October number 23, variant 52, paper 5, probability and statistics 1. Shortly named as S1. Okay, let's get into question number 1. In 1, you see a competitor in a throwing event has 3 attempts to throw a ball as far as possible. The random variable x denotes the number of throws that exceed 30 meters. Okay, the probability distribution table for x is shown below. And this is a table where you see two probabilities. Probability of x equal to 1 is unknown and probability of x2 is unknown as well. So two unknown need two conditions. Okay. Given that Ex expected value of x, Ex is 1.1, you have to find value of P and value of R. So it's a two unknown, we need two conditions, and the first condition is sum of all the probability is equal to 1. If we apply this one, we have 0.4 plus P plus R plus 0.15 equal to 1. So from this 1, you have, let's say, P equal to 1 minus 0.55, that is 0.5 minus R. That's the first equation. And the second condition is Ex equal to 1.1. Ex, remember, Ex expected value of x or mean is equal to summation of x times its probability, that's Ex, so which is equal to 1.1 equal to 0 into 0.4 plus 1 times P plus 2 times R plus 3 times 0.15. So we have 1.1 equal to P plus 12 plus 0.45. Now, let's substitute P here in terms of R. We have 0.45 minus R plus twice R, 0.45. So R equal to 1.1 minus 0.9, R equal to 0.2. And if R is 0.2, then P will be 0.45 minus R, that is 0.25. So that these are the value of P and R. Now, next one, you have to find the numerical value of R x, variance of x, whatever you call it. The formula for variance of x is, remember the formula, expected value of x squared minus Ex, that's the mean. Oh, yes. So Ex squared is summation of x squared into x probability minus this one. So it will be 0 square into 0.4 plus 1 square into P, 0.25 plus 2 square into R, which is 0.2 plus P square into 0.15 minus mean 1.1 square. So this is, we calculate this one, it will be 1.19. And we can write it in mixed form as well, 119,500. That's the variance. So that's question 1. So that's it. Now move on to question 2. In question 2, you have George has a fair five-sided spinner with sides labeled 1, 2, 3, 4, and 5. He spins the spinner and notes the number on the side on which the spinner lands. Find the probability that it takes fewer than 7 spins for George to obtain a 5. So you see, number of spins is not fixed, rather George will continue to spin it until he obtains a 5. So obtaining 5, probability of obtaining 5 is 1 by 5 since it's a pair threaded spinner. Okay. Now x here, the number of spins. X is number of spins to obtain a 5. So since number of spins is not fixed, we will stop spinning once we obtain a 5. So it is a geometric distribution because probability of obtaining 5 in a spin is constant, which is 1 by 5. And number of spins, number of pairs is not constant. So it follows geometric distribution with probability 1 by 5. Now, what is the condition here? It takes fewer than 7 spins. So x less than 7, that is x less than equal to 6. And remember, in case of geometric distribution, x less than r, the probability of x less than r equal to 1 minus u to the power r. E, which is 1 by 5, is the probability of success, that is obtaining a 5. E is probability of not obtaining a 5. So here, if we apply the formula, Q is 1 minus 1 by 5, and R is 6. So that's it. So it will be 0.738 if you write it correct to 3 decimal places. And if you want to get the exact number, or you can write it in fraction 11.59 divided by 15625. That's the probability of obtaining a 5 in fewer than 7 spins. Now, that's part A. Next, part B. This time, George spins the spinner 10 times. The number of spins is constant here. So there's no more geometric distribution. So this is binomial distribution. You have to find the probability that you obtain a 5 more than 4 times, but fewer than 8 times. So here the variable is a number of times or occasion or spin is obtained a 5. Okay. In that case, number of trial, number of spin is 10 and probability of obtaining a 5 in each spin or each trial is 1 by 5. So it follows geometric distribution. No, not geometric anymore. In the middle, between 10 is 1 by 5 and number of occasion he obtains a 5 is more than 4, less than 8. So it can be 5, 6, or 7. It can be 5, 6, or 7. That is 5, 6, 7. So remember the probability for the formula for animal distribution. Here it is equal to R, probability PR, NCR, P to the power R, 1 minus P whole to the power N minus 1. So when x equal to 5, probability N is 10, 10 C 5, p 1 by 5 to the power 5, 1 minus p, that's 4 by 5 to the power 10 minus 5, that's 5 as well. Then 10c 6 p 1 by 5 to the power 6, 1 minus 1 by 5, that's 4 by 5 to the power 10 minus 6, that's 4. Plus 10c 7, 1 by 5 to the power 7, 1 minus 1 by 5, that's 4 by 5 to the power 7. So that's the probability, and you add these three, you will have 0.0327 correct to the SF. Okay, now let's move on to the next part. Is there any further part in this question? No. So let's move on to question number 3. In question 3, you see a factory produces a certain type of electrical component. It's known that 15% of the components produced are faulty. A random sample of 200 components is chosen. Okay, use an approximation to find the probability that more than 40 of these components are faulty. You see number of samples. Sample 5, 200 constant, and probability of components being faulty is constant. So, you see, it's the binomial distribution, where X is number of faulty components. So, X follows binomial, where N is 200, and probability of success, that is probability of being faulty, is 0.15. So, here it is 1. But N is large here, you cannot. And the X probability, you have to find the probability for X greater than, more than 40, X greater than 40. And X greater than 40, that X can be 41, 42, up to 200. So it's quite impossible to calculate probability for each of these numbers and add those. So what we do here, we use an approximation. Okay, the binomial distribution, when n is large, we use normal approximation. In that case, we have to calculate the mean of the binomial distribution, which is NP. NP here 200 into 0.15, which is 30, and then variance NP into 1 minus P, 200 into NP is 30 times 1 minus 0.15, which is 85.5. So, you know the mean and variance. So, it will be approximated by the normal distribution, whose mean is 30, variance is 25.5. Now, you see, we have denoted the continuous variable by y, where in case of binomial distribution, the variable is x. You know the reason? Because binomial distribution represents the distribution of discrete variable, whereas normal represents continuous variable. So there is a need of continuity correction. That's why we need use here two different notations. First, and then since we are approximated the binomial distribution using normal distribution, the discrete using continuous, so you need to do the continuity correction. In case of doing continuity correction, if we place the x greater than 40 on a number line, x greater than 40, that is x greater than equal to 41. So continuity, do the continuity correction, extend the closed is shown by 0.5. So it will be y greater than 40.5, greater than or greater than equal to. Because in case of continuous variable, equal to sign does not matter. So now we have y greater than equal to 40.5. So use this double distribution. For this, you need to convert it into z. Remember, to convert into z, z equal to y minus mean by standard deviation. You see the mean is here, 30. So 40.5 minus 30 divided by standard deviation, which is the square root of 25.5. So it will be z greater than, keep the value of z correct to 3 decimal places, 2.079. Now, use the normal distribution table. We have the normal distribution table here, 2.079. 2.07 is here, 2.079 is 4. So you add this, we have 0.9812. 0.9808 or 0.0004. Okay, so that is, and we have probability z greater than. So it will be 1 minus probability of z less than 2.079, because from the table we can find the probability of z less than something. So 1 minus 0.9812, that will be the answer equal to 0.0188. That's the probability that 40, if more than 40 of these components are healthy. Okay, that's part 3. Now that's question number 3. Now let's move to question number 4. In question 4, we have to say the height in centimeter of the 11 players in each of two teams. The aces and the days are shown in the following table. Draw a back-to-back feminine diagram to represent this information with the aces on the left-hand side of the diagram. So we have to draw a back-to-back feminine diagram. Remember, in back-to-back feminine diagram, the stem should be at the middle. So at the line, now stem is here. Here is the stem. And we have the stem. Here the heights are in 3-digit number. Heights are 3-digit number, so the stem should be 2 digits. So for this, we have to figure out the smallest height, shortest height. How much is the shortest height for aces? It is, I think, 169. There is 168 and 164. That's the shortest height. So smallest stem for aces is 16, and the largest stem will be, see, what is the largest number? 182? No, 180. Yes, 182. So 16, 17, 18. These are the three stems we need for aces. What about J? For J, the shortest height is 160. It is in the this here, and the largest, I think, is 190 something, 190. Okay. So for the J, we need 16 to 19. So we have to combine these two. The then will be shortest then 16, smallest, then 17, 18, 19. Is there anyone in the into 100? No. Now, S's will be on the left and J's on the right. Now find the highs in the 16 10 for S's. There are three. There is there three, 166, 168, 164, anything, 169. No, there are four leaves. And the smallest, remember, the smallest leaves are closer to the stem and larger leaves are away from the stem, furthest from the stem. So smallest is 4, 6, 4, 6, 8, 9. And in the 17th we have 171, 173, 134, 134. So 1, 3, 4. And the 80 is 18. It is 182. So 2, 1, 2, 0. So 0, 1, 2, 2. 0, 1, 2, 0, 1. There are 11 units of S. Now for J, in the 16, 160, how many are there? 150, 158, 166, 2, 6, 8, 6, 8. In the 70s, there are 170s, 0, 4, 4, 5, 0, 4, 4, 5, 4, 4, 5, and in the 80s, 180, the 180s we have 188, 8, 1, 1, 8, 1, 1, 8, 8, 1, 1, 8, 8, and the 90s we have only 1 from 19. So this is the 7 is the diagram, and don't forget to save the key. So let's take an example. P in the left, I went in the 10, 4 in the left on the right. Means 173 centimeter for A and 174 centimeter for J. Okay, this is a family diagram. That's it. Now let's move on to the next part. Find the median and interquartile range of the height of the pairs in the axis. So find the median. You have to figure out the middle value. Which is the middle value? You see there are 11 pairs. The middle value is 6. Is the median. The median is 173 centimeter for axis, and the interquartile range IQR, remember IQR is Q3 minus Q1. Q3 is the middle value in the lower part, above, higher than 173. There are four, 5 numbers. The middle value is the third one. So this is 181, that's Q3. What about Q1? That's the middle value of the lower high, shorter high. Then 173, that should be 168. Yes, that's 168. So the IQR is 13 centimeter. Okay, the median 173 centimeter, IQR 13 centimeter. Okay, then the next part is C, give one. The next part, C, they're asking for give one comment comparing the spread of height of the edges to the spread of heights of the disk. If you compare the spread of height, if we consider the largest, shortest, and tallest, that case it is 164 and 182. The difference is 182 minus 164 is the 18. And for the dates, it is 190 minus 168, that's 22. So if you think of the spread of the height, it has very wider ranges of height compared to S. So jets have a greater variety of height compared to S. That's one statement is sufficient. Jets have a wider range of height or variety of height then S. Okay, that's it. That's part C. Is there any equal to part? No. So let's move on to question number 5. This question 5 is C. 5 in 5A. The heights of the members of a club are normally distributed with mean 166 centimeter and a standard deviation of 10 centimeter. Okay. Find the probability that a randomly chosen member of the club has a height less than 170 centimeter. So let's say h is the height of the member of the club. So h follows normal distribution with mean 166 and standard deviation 10. So variance is 10 square. Now we want to find the randomly selected member is has a height less than 170 centimeter. So this is the probability normal distribution. Convert h into z. Okay, remember the conversion? H minus mean divided by standard deviation. So Z is less than zero point 0.4, and from the normal distribution table, less than 0.4, probability is 0.6554. So 0.6554, if you keep the answer correct to CSF, this is 0.655. Okay, next part 2, given that 40% of the members have height greater than 8. Okay, so height greater than 8, chances is 40%, so 0.4, you have to find the value of a small 8. So first convert it into Z. 8 minus mean is 166, standard deviation 10, that's zero point 0.4, greater than 1. This 0.4, so less than this is 0.6. Now, 0.6 is the probability. You have to find the corresponding value of Z. 0.6. We don't have the probability 0.6000. Rather, we have 0.5987, which is 13. Yes, so we don't have 13 here, 12, so we can consider. This is closest, so we take this one. 0.3253. 0.253. So 8 minus 166 by 10 equal to 0.256. So from this one, 8 is 168.53 centimeters. Correct to two decimal places. That's it. Okay, that's part A2. Now let's move on to the next one. Next one, we have the random variable x is normally distributed with mean mu, standard deviation sigma, so variance sigma square. Now, it is given that sigma is equal to 2 by 3 mu. Find the probability that a randomly chosen value of x is positive. So you have to find x is greater than 0. Positive, that's greater than 0. So convert this x into z. We have x minus mean by standard deviation. Now, standard deviation is 2/3 mu. Substitute it mu by 2/3 mu. So this is z greater than minus 1.5, that is z greater than minus 1.5 is equal to z less than 1.5. So, and from the table we have z less than 1.5 is 0.9332. So point here it is 1.5, 0.9332, so it is 0.9332. That's it. That's the probability. You can see the probability correct to TSX 1933. That's it. Now let's move on to the next part. Then for the part in this question, no. Let's move on to question number 6. In question 6, we have Freddie has two bags of marbles. Bag X contains 7 red marbles and 3 blue marbles. Bag Y contains 4 red marbles and 1 blue marble. Freddie chooses Freddie chooses one of the bags at random. A marble is removed at random from the bag and not replaced. A new red marble is now added to each bag. Okay. A second marble is then removed at random from the same bag that the first marble had been removed from. Draw a tree diagram to represent this information, showing the probability on each of the branches. So whenever we are doing the tree diagram, we have to find the sequence. First, we choose the bag, then pick the first marble, then pick the second marble. First, first branches are about the bag to choose, bag X, bag Y. Both bags, there are one bag of each, so both of them are equally likely, the probability is up. And from bag X, if you choose the first marble, then it can be either red or blue. The probability of being red of the first marble from bag X is 7 by 10, blue 3 by 10. Once you choose the first marble, then this is not replaced, and one red marble is now added to each bag. So now in bag X, we have again 7 red marbles and 3 blue marbles. If the first marble is red, so if the first marble is red, then the second marble being red has the same probability, 7 by 10, that's 2 by 10. If the first marble student from bag X is red, then we have eight we'll have 8 red marbles and 2 blue marbles in the bag. So probability of red marble being chosen again will be 8 by 10 and blue marble 2 by 10. Okay, now what happens if Freddie chooses the bag X? In that case, bag Y has 4 red marbles, 1 blue marble. So probability of first or marble being red is 4 by 5, blue 1 by 5. Then if the first marble chosen is red, another red marble added to the bag. So now we have the same number of red marbles and blue marbles. The probability of being red is 4 by 5, being blue 1 by 5. What happens if we have chosen the blue marble, the first case? Then now we have another red marble added here. So 5 red marbles, 0 blue marbles. The next marble being red is 5 by 5, that's 1. And blue will be 0 by 5, that's 0. So this is the probability of a branch, and that's the tree diagram. Okay. Now, what is in the next part? Next part, find the probability that both of the marbles removed from the bag are same color. Then what are the branches here? This is the branches where the same color, or we have this branch. Okay, this is X red red or X blue blue. Then we have Y red red, and we have Y. Although Y blue blue is not possible because second marble being red is not possible. So both marble being same color will be same color will be X, red, red, X, blue, blue, Y, red, red, and Y, blue, blue. Although Y, blue, blue, the probability is 0. So this is half uh, 10 by 10 times 10 by 10. Then half 3 by 10 times 2 by 10. Okay. Then half 4 by 5, 4 by 5, plus half 1 by 5 into 0 by 5. So the total probability is, if, if you want to write it in exact fraction, 119 by 200, or in decimal, it is 0.595. Okay, that's part B. Now let's move on to the next part C. Find the probability that bag Y is chosen given that the marbles removed are not both the same color. So we know the probability of same color. What is the probability of not same color? Not same color. Probability will be 1 minus probability of same color. That's 1 minus 0.11, 0.595. 1 minus 0.595. And Y. Probability of Y given not same color, different color. Different. Okay. So it is conditional probability. The probability of the condition will be in the denominator. Different color. The numerator, it will be Y intersection different color. Now, what is the probability of this? Y intersection. If you look at the tree diagram, we are picking from the Y and it will be different colors. So this is Y red blue or Y blue red. Okay. So Y red blue, Y blue red. Half, half 4 by 5 into 1 by half, or half 1 by 5 into 5 by. Okay. So these are the two answers. The numerator we have half 4 by 5 into 1 by 5 plus half 1 by 5 into 5 by 5. And in the denominator, there is 1 minus 0.595. So this is 4.9. If you calculate it, there will be 4 by 9, or if you keep it in decimal, it will be 0.444 to 37. Okay, that's part C. Now let's move on to the next part. Is there any further part in this question? No, so this is question 7. Okay, in question 7, you have to find the number of different arrangements of the 9 letters in the word Andromeda in which no consonant is next to another consonant. The letters D, M, N, and R are consonant, and the letters A, E, O are not consonant. Okay, so first of all, there are 9 letters. How many A are there? There are 2 A. 2 A, and repetition of O, E. There is single O, single E, one O, one E, and there are two D, two D, and there are R, M, N, R. These are the 9 letters. Okay. Now remember, the consonant cannot stand next to each other. But we have 4 vowels, non-consonant. Now, if we figure out this 9, let's say these are the non-position. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 positions. There are 4 vowels. If the consonants are not next to each other, there are 5 consonants. So these are the places for the consonant. The odd places. 5 places for 5 consonants. And 4 places for 4 non-consonants. So you have to place these 4 vowels in this 4 position and the 4 consonants in the 4 position. The total number of arrangements. Number of arrangements will be 5 consonants, 5 positions, factorial 5. Among them, we have 2 D, so there's the factorial D, 2. And 4 vowels, for non-consonants, factorial 4, divided by there are 2 A's among them, so that divided by factorial 2. So that is the number of different arrangements, 720 arrangements. Then in the next part, what we have in the next part, find the number of different arrangements of the 9 letters in the word Andromeda, in which there is an A at each end, and these are not together. So out of these 9 places, 1, 2, 3, 4, 5, 6, 7, 8, 9. A's are at each end. So there will be 2A on each end. A here, up there. So these 2 positions are fixed. Remaining 7 positions, 7 letters, but remember, these are not together. So how can we do it? Let's say these are together. Let's consider the situation. First, we find the total number of arrangement without any restriction of the 7 letters, factorial 7 by factorial 2, minus 2 these are together. So, total number of arrangement. Without restriction, factorial 7 by factorial 2 with these together. That is, if you consider 2D as a single letter, then we have 6 letters. The 6 letter can rearrange in 6 position is in factorial 6 ways, and the 2D cannot rearrange among themselves, so for the so 2D together. This is without restriction. So that is, if we subtract this, we get the total number of different arrangement in which 2 A's are at each end and 2 D's are not together. And this number is equal to 1800. Now, there is another part to this question. Let's move on to that part. See, 4 letters are selected at random from the 9 letters in the word Andromeda. Find the probability. See, whenever we are selecting letters, and we have to find the probability in number of combination, number of letter selection. Normally, what we do, if there are 2 identical selection, we consider it as a single selection. But whenever you are considering, you are finding the probability, using selection, you have to take those two identical selection as two selection, not as a single selection. So that is most important thing whenever you are finding the probability using selection, not analysis. Okay. So here, first let's what is going to find the probability that this selection complete contains at least one D and exactly one A. So what are the scenarios? In a possible scenario are if we select one D or two D, we have two D, we have two A, we have other five letters. So from 2D we select 1D, 1A, or other five we select 2. That's 4. We select 2D, 1A, there is 1 from the other five. So these are the scenarios. And here the number of selections. Remember, identical, although there are some identical selections, but we will consider them as prepared selection. So we'll consider all of them. So from 2D, we can select 1D in 2C one way. From 2A, select 1A in 2C one way. From 5 other letters, select 2 letters in 5C2 way. And from 2D, select 2D, 2C2. From 2A, select 1A, 2C1 into 5C1. One letter from the 5 different letters. So these are the number of selection where we have at least 1D and exactly 1A. Now, from 9 letters to the restriction, number of selection, 9, 3, 4. Although among these selections and these different selections, there might be some identical. Okay, since we are considering the probability, we are finding the probability, you have to consider the identical selection as separate selection. So total probability will be, okay, you need to calculate this one. This one is 40, this is 10, so this is 50 divided by 94. How much is 94? That is 126, I guess. So 50 by 126, that's the probability, 53, 25 by 56. Yeah, that's the probability for this. Okay, that's part C. Now let's move on to the next question. Is there any question? No, that's it. That's the end of this paper. Okay, guys, that's it. Please don't forget to like the video and subscribe to this channel if you have any queries about any part of this question paper. Don't forget to write your queries in the comment section. I'll try to attend it as soon as possible. Okay, until we meet in the next video. Until then, Allah Hafiz. Assalamu alaikum.